Wireless security. So going ahead with the wireless security and others, just with the little bit of the introduction part. It's like why this wireless security is required, and it's like going ahead into this wireless security. There are something which plays an important stuff. That is the authentication infrastructure, the radio security. Yes, speaking about this authentication infrastructure, the main authentication infrastructure which comes into the picture is called as a radius. It's called as a remote authentication dial-in user server. So that is what the radius server plays a very important role. And going ahead into this radio security, this what is the main purpose of this radio security is definitely to ensure the confidentiality, integrity, and packet signature. And yes, it provides the services are delivered, such as this WEP, wired equivalent privacy, this TKIPs, this temporal key integrity protocol. So all these stuff forms the radio security. And this the attacks on the wireless security. So there are multiple attacks which happens on a wireless security. So what literally happens? The thing is, it's like it may be kind of a security things and other stuff. So this network security attacks are divided into passive and active attacks. So these are the two kinds which can be bifurcated. So that is what we are going to see how these kind of attacks are classified. And the first one is the passive attack. So under passive attack, we have the eavesdropping and the traffic analysis. So it's like under the passive attack, the eavesdropping. It's like what will happen is the attacker he'll just listen to the transmission in order to receive the content of messages. It's like that is what it's called as eavesdropping, kind of listening stuff. So it's like a person listens to the transmission over a LAN network between two stations or between a wireless phone and a base station. And the second one is the next one is the traffic analysis. The attacker obtains information by monitoring transmissions to detect different types of classical modes. Right. So this is a traffic analysis between the communicating parties, that is the transmitter and the receiver mainly. And yes, active attacks. When how do we call this attack as active? When this attack makes a unauthorized access. Like imagine we are transmitting a message, and when it makes an unauthorized access, so at the time this kind of an attack is called as active attack. And there are some active attacks. That is the masquerade. The names masquerade, the replay, the message modification, and the denial of service. So these are the things which comes under the active attacks. Masquerade. Yes, the attacker what he does is impersonates an unauthorized user. Okay, so it's like an unauthorized user comes into the picture to access the certain privileges. And the next one is replay. What happens is the attacker will monitor the transmissions. Like he'll be having the he'll be having the privilege to, I mean, he'll take the privilege to monitor the transmission. The next one is a message modification. So what the attacker will do is he'll alter a legitimate message. So the attacker, yes, he'll enter into the mode and he'll alter a legitimate message. So he has access by deleting, adding, modifying, or rearranging. So all these stuff. So he has access of, he'll take the access of doing that. That is message modification. And the fourth one is the denial of service. The attacker, what he'll do is he'll prevent or prohibit normal usage of the management. So DOS, that is called as DOS. And the denial of the service attacks. And comparatively, this denial of service attack is one of the simplest attack. Comparing to other attacks, this is a kind of simple attack to implement. And it is generally very difficult. It becomes very hard to deal with wireless networks. So it's like what it will do is in a wireless network it will just combine making a large number of requests, right? So it keeps on flooding with the request. So what happens, and finally the access point, what will happen to the access point, it will crash. So it will be keeping on bombarding that large number of requests. Okay, so it's like but how do we, what kind of a countermeasure can be adopted? So the only countermeasure which can be adopted is determine the point, like figure out the point from where the attack is coming. Okay, and then what we can do is we can launch a human neutralization. And the next one is the TCP attacks. Speaking about the TCP attacks, the TCP protocol with same port numbers and what is it? It will determine a socket address, network access point. It's like each application will have a port number. That is, for example, 80 for HTTP application. For everything, there'll be a port number. And what happens is this TCP attack will happen if the access point is forced to behave in the way. It's like the attacker. What he'll do is he'll use a classical port to enter. There'll be a classical kind of a port stuff. The attacker, what he'll do is he'll use a classical port to enter in the computer. So once when the user opens a TCP connection, the available TCP connection, the hacker, what he'll do is he'll start to use the same port disguised as a user and it's send response. This is a kind of a TCP attack. So it's like this is also kind of a thing which has to given a very high priority. And Trojan attack, a very famous attack. It's like so. Speaking about the Trojan attack, what the attacker will do is the attacker will himself introduce into the terminal section a program. Okay, he'll just introduce a program, and what the program will do is it will memorize the login and the password. Okay, and it's like this information, like the login and the password, will be sent to outside by a message to an anonymous mailbox, right? So it's like there are many techniques used for this. It's like the kind of a program that replaces the login manager to a hacker program. So this is how it does. So it's like so where it is this kind of attack is predominant is this kind of attack, this Trojan attack is very predominant in wireless networks. Yes, very predominant. It's like by installing a spyware and allowing him to take the place of the user. And dictionary attacks. So it's like what does this dictionary attack? So it's like we have some passwords. Okay, so the many chosen passwords are in the dictionary. So it becomes easy. Many experiments, it's like demonstrate the simplicity of this attack. But how does it? How is made complicated? It's by adding passwords to capital letters. That is how do we create avoid this dictionary attacks. Okay, to what you do is keep your passwords complicated by adding letters, capital letters, numbers, and symbols. And speaking about this dictionary attack, it is one of the most common attacks in wireless networks that are protected only by user passwords. Other than that, it cannot be what I say. It cannot be controlled or whatever. That is what has to be done. Dictionary attack is one of the most common attacks. And yes, next comes the security in IEEE 802.11 standards. That is the Wi-Fi implemented in Wi-Fi standards. So speaking about the security, it's like how do we improvise or improve this security mechanisms, right? So that is what we are going to see some stuff like how these things plays a vital role. Yes, as you could see, it goes ahead with the three states. We can create a what to say a three-state mechanism. So the state one, state two, state three. The state one is unauthenticated and can be a kind of unassociated, and the state two is authenticated and non-associated, and state three is unassociated. I mean, authenticated and associated. So these are the things which what to say can be delivered as a state mission for authentication in 802.11. So we can follow this. So this could help out for an authentication. And WEPs. WEP is the wired equivalent privacy. So it's a kind of a symmetric cipher. It's a kind of a symmetric cipher, and it is created to satisfy access control, privacy, authentication, and integrity. Okay, to improve all this stuff, this WEP can be used. And the access control. Speaking about this access control, it can be done on, it's a two way. It can be done on both sides of communication. It can be done on the client side and the server side. Okay, so it's like, for example, the banking services. It's like imagine the client is logging in, connecting to a bank. What will happen from the server side is it will push out whether it's the original customer. So it will have the verification process. And if it's the original customer, it will check out the credentials, logins, passwords, and other stuff. Then it goes ahead with the provision of rights. Okay, so this access control is one big important medium. And yes, going ahead with the SSIDs, the network identifier, the service set ID, right? So it's like it's the first mechanism of security offered by WEP. So the network name. So how it is done is the network name is primarily used at the network configuration. And the next one is the ACL, the access control lines. Okay, so it's like what this Wi-Fi manufacturers will do is they'll implement the ACL, the access control list, on the MAC address. Okay, so the point, what it will do is it will perform the combination of terminal only if the MAC address of the terminal is in the ACL. You will see how this matching is done. So this is an optional mechanism. This is rarely used because it is unreliable. Okay, and yes, there are some things which goes ahead, that is the confidentiality. Sometimes this what to say, the transmitted frames in wireless networks are protected by encryption. So by obtaining the key, the RC4 performs the encryption. Okay, and this is how this encrypting a web packet, WEP packet, looks out. And the next one is authentication. Two types of authentication procedures are available, can be used. One is the open authentication, and the other one is the shared key authentication. Right, there are two things which can be used. So the open authentication is the default process, and it contains no express authentication. That is, you'll have the terminal can access with the access point. And the shared key authentication, comparatively, this provides a better level of security. And how it provides an authentication, we can see in the probably the, yeah, the figure. It's like you could see this is the WP authentication. So it's like you can see the first thing is the authentication request. The next comes the authentication challenge. Next comes the authentication response. What kind of a response which comes up, and finally the authentication result. Okay, so these are the four WP authentication mechanisms. So it's first, what the WLAN will do is it will, if it requires an association with the access point, it sends an authentication request, like it will send a request. So once when the access point receives the frame, so it will just sends to WLAN station the frame containing 128 bits or whatever. And what the station will do is it will copy the challenge in an authentication and it sends to the access point. And what this access point will do is it will decrypt the message. Okay, and will decrypt the message with the help of the secret key. And data integrity, this CRC, the cyclic redundancy check, the 32 bit based on the block, right? The ICV is encrypted with the same key that uses for encryption. And the WP shortcomings. So when you speak about the shortcomings, some kind of some weakness or whatever, the shortcomings are not related to RC4, but implement that is. But this the one of the mechanism has some defects, making it possible to break the WP relatively quick. Yeah, sometimes this could happen. And yes, there is something called as unique key. So it's like what we try to do is we try to define a key size of 40 bits. Okay, so that which is too short to counter attacks. Yes, so it would take no less than dozen hours to break. So this is one kind of a structure which comes into the picture. The next is IB collisions. It's like the collision attacks. Speaking about the collision attacks, these are the kind of passive attacks which can break from the key. So this type of attack include the IV collisions, the weakness of RC4, and all these things plays a vital role. And speaking about this encryption, this IV collisions, this IV is 24-bit and may go up to 2.24 or 16 million different keys. So it could go like this. And this RC4 weakness, this WEP has a drawback. It's like what could this what could be the thing? The key is for RC4 algorithm is concatenation of IV, and this is the secret chat key. So it's like this kind of robust structure It's has kind of a weakness. Okay, so the drawback facilitates the detection of key by the statistical attacks and based on the fact that encrypted corresponds to the frame. So it's like the attacker can determine it by processing enough packets. And this SSID is used to access the wireless Wi-Fi network. In this SSID, what it has is it has a mechanism called the closed network, prompts the transmission of SSID through the beacon frame. It's like once when this network is closed, what the user has to do is the user must manually enter the network name, the SSID. Okay, without while in an open network, the user ID directly joins the access point without having to manual configure. Okay, so here the manual thing comes into the picture, and another disadvantage of this SSID is the SSID is usually pre-configured at the access points. Yeah, that is a bit of drawback. So each manufacturer will have a default SSID. So, for example, Waveland Network or Lucent or Tsunami and system. So the SSID is not changed by the user. Any person who knows a brand, imagine a person knows a brand of the access point may attempt to use the default SSID to access the network. And speaking about this ACL, the drawback of ACL is optional, and yes, it's optional and very rarely used. So it's like if a person has a MAC address, it listens to the network and identity authorized MAC address will transmit it clear. So this is one big drawback. And speaking about the attacks, there are some attacks which comes into the mode. The replay attack. Okay, it's a kind of shared key authentication. So that is a kind of drawback. The attacker, what he'll do is he wants to authenticate. Well, just listening to the dialogue. So what he'll do is he just try to listen to the dialogue, obtaining the challenge text pass message with access point and the challenge cipher text C sent by the user. Then what he'll try to do is then he'll try to reuse it. So okay, so once recovered CNP, it becomes very easy to reduce the encryption flow. So this is one kind of a replay attack. So this is how the replay attack. Yes, the next one is DOS. So speaking about this DOS, it's a kind of widespread of all networks. So the networks operating in 2.4 and 5 GHz frequency and uses a radio device. So the Wi-Fi, what it can do is it can use interference and this drop in overall performance network. Okay, so the DOS occurs. This attack is very easy to implement. It is also unfortunately unstoppable. So this DOS it's a bit thing which is unstoppable, and there are some examples which illustrate this DOS attacks. The best live examples: the disauthentication and disassociation of frames, and the second one is the reservation mechanism. Right, the disauthentication and disassociation allows either. I mean, speaking about this disauthentication, the type of frames allow either disauthentication or dissociation from an access point. Whereas in the reservation mechanism, it's like the media reservation is based on sending this frames. Okay, so it's like if an attacker will be sending an RTS frame and renew the sending frame every 32 millisecond, it prevents access to all the support of the stations in the cell. So there is no transmission is possible. Speaking about the security in 8.2.1x, so the security is also a prime factor. So speaking about this in 8.2.1x, the suppliant or the client, it relies on three functional entities: the supplicant or the client, the authenticator or the controller, and the third one is the authentication server, right? Typically the radius and other stuff. So these are the three functional entities. As you could see, this is the 802.1x architecture. So the thing comes with the supplicant, the client, and the authenticator. So it provides, it has a bit of access point, and next comes integrator of the internet and the radius authentication server. That is how this 802.1x architecture looks. And the authentication by port. Definitely, this 801x standard defines a control access network. So this actually it's an association between a station and an access point. So the control port, what it will do is it will behave like a switch, like a switch between the two states. So in the unauthorized state, only the frames dedicated to EAP authentication are not blocked. So this 802.1 standard defines encapsulation techniques to carry EAP packets. So it's like the access point retransmits the lost EAP frames every 30 seconds. So whenever the frame is lost, this EAP frames, the access point will retransmit the lost EAP frames every 30 seconds. And the authentication procedures, like the station authenticates. To begin the authentication, the station will broadcast a start signal, then the access point will send a request identity. So from this parameter, access point deduces the identity, therefore the request and the response are exchanged in radius. The radius server indicates the success of the failure procedure. At the end of the authentication procedure, the radius access message calls as a transition in the state. So this is how the transmission takes place. And yes, what you can make out is the authentication, and the last one is access point when selects an encryption key called a global key. So it's like to the security association. So this is how it looks. What you can see is this is the authentication procedure. The client, the API request identity, the API request identity through the radius, and the radius reverts back request one, the multiple request coming into the picture, and the EAP over the LANs, and the EAP over the radius. So this is the kind of an authentication procedure which supports. So with the kind of what to say, the nine levels, like nine different sequences. So the last will be the ninth one. That is, the access point will select an encryption key, so kind of a global key, and it's like so that the association with 802.1x client. So the later will be encrypted and signed with the session key. Okay, so thank you.